So, good afternoon, everyone. Thanks for coming to this session. And just to make sure, you're here to learn a little bit about gRPC, which is a RPC protocol that's open sourced by Google last year or something like that, and how we can actually use it to create like a microservice that's actually quite efficient and scalable. My name is Ray. I'm a developer advocate for the Google Cloud Platform. Now, hopefully everyone here now heard about Google Cloud Platform, right? Because we had a 5-minute talk on this previously. How many people are using it? Anyone? All right, fantastic. Well, you don't count, but that's pretty cool. If you haven't tried it, again, just remind you that you do get $300 free credit if you sign it up to use it. Yeah, so give it a try. And part of my job is to actually bring some of the latest and greatest technology to developers like everyone that's here. My other side of the job is to actually hear about how you're using the technology today. I want to hear about your feedback and your experiences in developing your application. And if you want to bring it to cloud, I'd love to hear about that as well. So please feel free to contact me. The best way to do it is with Twitter @Satanism. That's my Twitter handle. Okay. And I've been traveling around the world for the past year to many different places and teaching developers how to use another open source project of ours is called Kubernetes, right? I teach people how to use this to manage their microservices applications and platforms. I'm going to have a session tomorrow on this with a workshop. In fact, Anton also has a session on this tomorrow with a workshop. So his is in the morning, mine is in the afternoon. So there's no excuse that you don't go try this, okay? But you gotta go try it. But I talk a lot about how to manage your microservices. I rarely talk about how you can actually create one, how you can actually write one that's efficient and scalable. And for the most part, many people are using monolith today. There's no theory here. You make your decisions on what you want to do. But so if you decide that you want to break out your application into individual services, well, there are two problems you're going to solve. The first one is how do you actually manage all of these instances, all of these applications. I have one person who just came to me a couple hours ago, like, we're doing microservices, but there's so many instances of these. How do I manage it? Okay, and for that, you come to my session tomorrow. But the other problem is how do you actually communicate between all of these services, right? When you're monolith, you do everything within the same JVM. Now you're actually going to be communicating over the network. You're going to have these message payloads you have to define, and you have to have these client libraries where you can actually contact the server and pass the messages. And for the most part, people are kind of bought into the whole the RESTful services, right? With JSON over HTTP. How many people are doing that today? Yeah, almost everyone is doing that today. And there's nothing wrong with that. I personally believe that it's a really good use case, for example, for applications where you're facing the front end, like it's a front end application where the browser needs to get the data. But within your internal applications, within your internal services, where it's just using service A calling service B, sometimes JSON over HTTP may not be the best solution because it is actually a plain text protocol over HTTP. And it may not be as efficient as it can be for internal communications, okay? So what do we actually do at Google? We actually use our own internal RPC protocol or library, and this is called Stubby. It is binary protocol, and we actually make a call. I didn't know about this before. We actually make 10 to the 10 RPC calls per second, okay? That's what we're doing today. And we're able to do it for a couple of reasons. One is that we use the bandwidth very efficiently because Stubby is proprietary, it's a binary protocol. Okay, it's very efficient in terms of how we pack the messages together, how we pass them around. Now imagine if all of these messages are just like 1 byte larger. Okay, then you're looking at 10 to the 10 bytes more data we have to transfer. That will be a lot, right? The other thing that we do within Google Data Center is we actually do about 1 petabits per second bisectional bandwidth in our data center today. Now, to put that into perspective, the entire internet runs at about 250 terabits per second. And we're doing 1 petabits per second internally. But that's necessary because we need to we have all these services running, we need to pass the messages around. But we also try to use efficient protocols to do this, right? And internally, we're using Stubby. And some of you may be thinking, RPC, how many people have done RPC before? As you can see, yeah. How many people give up on RPC? Yeah, that's what I thought. And you might be thinking, wait a second, why are we still talking about RPC right now? When I started doing distributed computing and distributed system, I was using Corba and DCOM just like everybody else. I don't know if anyone tried it. How many people tried Corba before? Yeah. For those of you who hasn't seen it, look what I found on the internet the other day. It's pretty funny. It's a tutorial on how to write a Corba service in Java. And first you define what the service should look like by using an IDL. I just found this on the internet the other day. Right? You define the IDL, which is interface definition language, which is fine. I mean, there's nothing wrong with it because you want to define your service with like a very concrete contract, right? And in different frameworks, you do it differently. With Corba, you use IDL. In SOAP, you use WSDL. In REST, you probably want to use something like Swagger, right? So that's what people do. And then I scroll down like, okay, how do you implement one of these services? And this is how you implement one. It's not too bad. It's just adding two numbers together, okay? It's just adding A and B together, return one value. And then I scroll down a little bit more, and and I'm like, how do you start the server? And I'm like, oh my goodness, like this is the code you actually take to run one of these services. And this is just starting the server. And I was just dumbfounded by it because I haven't done this for a while. I'm like, that is way too much. And then if you look into the client side, it's not any better, okay? And for the most part, RPC has this bad rap of it being a little bit too complicated to do, which I can definitely see why. And then there's RMI, Java RMI, which is simpler to do, but it is not as interoperable as some of these other protocols either. And then we have SOAP. I love SOAP. Who loves SOAP? Am I the only? Yeah, there you go. There's always some people who love SOAP. Who's still using SOAP today? It's okay. Yeah, that's what I thought. Yeah, but you didn't like it, did you? But again, it's not the most. It is very interoperable, right? It's using XML for the messaging, but again, it's not the most efficient. It's very bloated in terms of the amount of data you have to send and process. But why RPC though? Why would I still be talking about and recommending RPC? Well, for a number of reasons. First of all, they can be very, very efficient in terms of the bandwidth, okay? Because they're mostly binary protocols. And they can be also very efficient in terms of CPU utilization because they are usually very fast in terms of marshalling and marshalling of the data. If you're using XML or REST, JSON, for example, you will be spending a lot of the processing power just to marshal the data itself. The other thing about RPC is when you define these things, you have to define it with like IDL, and your service has a really nice contract, and everything you generate can be strongly typed. And assuming we're all Java developers here, and we like strongly typed things, I suppose, right? And that's really nice with RPC. The other thing is that there are certain operations when you're doing these microservices calls. There are certain operations that you just simply cannot express in REST easily, because REST is built on top of resources with HTTP, and you use the verbs, HTTP verbs, to describe what you want to do, whether it's a put, a get, a post, or a delete. But that's pretty simple CRUD stuff. When you need to go beyond that to do something more complicated or more sophisticated operation like, I don't know, withdraw money from some account, it could be composed of multiple transactions or multiple CRUD operations, or like registering a user. It's all of a sudden like your business operations, it becomes really hard to express in RESTful manner. And RPC gives you the opportunity to really describe your service operations very, very clearly. But it has to be something that's simple to use and also interoperable between different languages, because today people develop with the language that is best suited for the job, and you want your services to be able to communicate with each other easily. Okay, and that's where gRPC comes in. gRPC stands for, the G actually does not stand for Google. The G, RPC is actually a recursive acronym. It stands for gRPC Remote Procedural Call Framework. And it is simple, it's idiomatic. It generates the stub code for you in the language that you want to use. And it actually makes sense. People may have tried to use Whistle and generate the stub before. And sometimes the stub does not make sense at all. And it depends on which generator you use, right? Sometimes it looks like this way, and the other it looks something completely different. But gRPC, the generated code is pretty consistent. It's idiomatic for the language you're generating to. It's performance scalable. I'll show you some slides on that. And it's very interoperable. The base technology it is using, well, first of all, it uses IDL, which is based on protobuffer 3, so that you can define your message payloads very clearly, and then you can define your services very clearly as well. I'll show you the demo in a second. But most importantly, it is not using a proprietary TCP protocol. It is also not using HTTP1. It's actually using HTTP2. Okay. I think today there was some mentioning about HTTP2 already. Again, it's about adoption, and HTTP2 has some really, really nice features over HTTP1. I'll just show you a real quick demo of HTTP2 in action, and you can actually try this yourself when you get home. There is this website called the HTTP2 demo.io. If I were to refresh this page, this is actually loading these individual tiles of images. This one big image is composed of smaller images, so it's trying to load all of these smaller tiles over HTTP1 connection. And because of it is HTTP1, every time you're trying to request for a resource, it actually tries to open up another connection, right? And this, by the way, this is not cached at all. And I'll show you an example of HTTP2. That's HTTP2 right there. Did you see the difference? None of these are cached. And how does that actually happen? Yeah, someone is like, what just happened? Let me do a refresh, okay? HTTP1, yeah, HTTP2, just like that, right? The way that it works is that behind the scenes, HTTP2 actually supports connection multiplexing, okay? So rather than being able to, or requiring to open up multiple connections, HTTP2 also allows you to have multiple streams of data in a single connection. And that solves a lot of problems behind the scenes. I cannot go into all the details today. Just know it has multiplexing. It also supports streaming from the server to the client as well. So if you're thinking about WebSocket, right, that's still over potentially HTTP1 connection, but it gets dropped from time to time. This is actually real streaming from server to the client and from the client to the server as well. You can do bidirectional streaming. The protocol is also binary, so it's very efficient. All the common operations you do, like the get, the put, the post, all of them are encoded in binary format. Okay, and all the headers that you're passing around, all the HTTP headers, they're also compressed. So you don't have to send the same headers over and over again. You can just use some kind of encoding to express what the header should be. Okay. That's why it is so fast. You should try this yourself as well. And just to show you a little comparison before I jump into a demo, this is a comparison between a gRPC throughput versus a REST throughput. And without going into the details, it's using the same number of machines, the same type of messages. And the gRPC, here easily beat out in throughput over REST by 3 times. Okay, the same messages. But if you look into the data a little bit closer, what you're going to see is that per CPU with gRPC, because first of all, it's binary, it uses protobuffer for marshalling and marshalling, so it's actually quite fast. With the same number of CPU for a single CPU, for example, you get 30 bytes per second throughput, and whereas REST over JSON, JSON over HTTP, because again, it's RESTful APIs, just JSON marshalling, it's much, much slower. You get much less throughput on that. And this is actually quite important if you're building a cloud-native application, and if you're trying to break down your applications into microservices, right? This makes a huge difference in terms of how much resource you actually need to run your application in the cloud. And for the cloud providers, obviously the more you use, the better. But from your perspective, the less you use is better, right? And for you to get that efficiency, you have to use the right tools to get there, right? Yes, question. JSON versus HTTP2? Oh yeah, I gotcha. Yeah, I don't have that number right now. Yeah, that's a good thing to check out as well. Yeah. But before I jump into the demo, I just want to show you some of the languages that gRPC supports. C++, Objective-C, everything, Python, Ruby, Node.js, and Java, of course. But if you look closely, Objective-C, C#, and Java happens to be used by some of the major mobile devices, right? So gRPC was actually built with the mobile in mind. You can actually use gRPC client on your mobile devices to talk to the server and get that efficiency so that when your users are on the cellular network, they can also communicate to your services via HTTP2 with these compressed binary protocol as well. So the end result is that you get faster responses for data on your devices, and it uses much less battery, right? Because you have less data to send as well. Cool. So why don't I just jump into it? Has anyone here used gRPC before? Is this the very first time you're seeing it? Yeah. I think it's probably the first time for most people are seeing it. So I'm going to do a few things here. Let me see the time. It's 5:50, so I have like, bless you. So I'm going to do a few things. I got a lot of demos here, but I kind of have to pick and choose which ones to show you. And the first one, I'm just going to do something very, very simple on how do you actually create one of these gRPC servers. And it will just be as horrible as Corba. No, I'm just kidding. No, it won't. The first thing you do is to define a IDL. And the IDL, like I said, is based on protobuffer 3. And the way that you create it is by creating a proto file. This is actually an example service.proto. Okay? And the first thing you need to do in gRPC is to specify this file and make sure that the syntax is proto 3. That's the number one thing you need to do. And then you can set the package for this proto file and every other messages that's in here. And this package can be just like a Java package as well. I can call it common.example.grpc. Whatever services. Doesn't matter. Can you see? Yeah, you can see. And then you can actually add some specific options that's specific to the language or to the gRPC compiler that you're using. So in this case, since I'm generating Java classes, I can say I can set an option that says Java multiple files is equal to true. And what this is going to do is that by default, it's going to generate all the message objects by wrapping it inside of another class. But by setting the Java multiple files to true, it will actually generate individual files instead. Okay, and then we can actually go ahead and define my message. And this is how you can do it. So you use the keyword message. You can give it a name like hello request, right? Rather than class, you just say message. And then you can add additional fields into this payload. And you start with the type. So in this case, I can use a string. And then the name of the variable. And I can give it a tag. Now, this numerical tag is very important. This is actually what identifies this particular field. Now, remember, in JSON, you identify the field by the name of the field itself. In this case, if the field is called name, it's going to take up 4 bytes, right, just to transfer it. In protobuf, it's going to use the tag. And that would just be 1, which can be encoded in just 1 byte. Okay? So the values between 1 to 15 can just use 1 byte to indicate which field this value is for. You can also do a few other things. Obviously, you can do other types. There are many, many different types it supports. I can say age is, say, 2. And you can also do a list, right? That list is very important if you need to respond with multiple objects, or if you need to send in multiple things. So you can do something like a repeated. So you can say repeated anything. You can say repeated string. My hobbies maybe is equal to 3. And that will generate a list of strings for me. You can also do, there are a few other primitive types you can use here. You can do a map, right? Just like Java, you can do a map with strongly typed key and value types as well. So I can say string and string, and my bag of tricks, which I have none. Okay. And finally, Another type that you can use is called an enum, right? Just like Java, you have enums. You can also use an enum here. So I can do an enum sentiment, which is like how good I'm feeling right now. Feeling happy. So happy is 0. I'm going to assign the value. Sleepy, that's probably how you feel right now. So I'm going to say sleepy is equal to 1. Angry, by the time I'm done with the talk, you'll be angry. So I'm going to set that to 2. Yeah. Hopefully not the case. But you get the point. The sentiment, and then you can just use this type, and you can give it a tag. And that's it. That's how you define the message. Very, very easy to do. Yes, you can also define embedded. Yeah, you can do that. You can also nest it as well. And you can also import other message types into here, just like if you want to do an analogy, it's like Java classes in a way. Okay. So let me go ahead and define another type here very quickly. I'm going to do a message hello response. And then I'm going to say string greeting is equal to 1. Okay. Now I have my messages defined, my request and my response. Now I can actually define the service itself. Okay. And the way you define the service in gRPC is by using another keyword, service. And I'm going to call this hello service, like that. And then I can define the operations I want to define in this particular service. So I can do something like you start with RPC, greet, and then the input type, and then you return the return type. So hello response, just like that. And that's it. That should be it. If I didn't miss any semicolons, that should work. Okay. But that's just the definition language. Okay. It doesn't actually generate any Java files just yet. There are multiple ways to actually generate the stubs for you. You can actually download what we call the protobuffer compiler or proto-C to process this file, and then you run the generator to actually generate the actual Java file. But that's actually an annoying process to do it yourself. So what we have done, or some of the other people have done, is by providing a plugin to do this for you. And if I were to go back and if I were to look up on GitHub, it's really to do. So gRPC source code is on GitHub, and in the README, there's actually this big, huge set of plugins you have to set. Actually, there are only 2. And all you have to do is to paste it in here, and that should be it. But I'll tell you what these plugins actually do. The first plugin here is called the OS Maven plugin. And what that actually do is to, during the build time, the plugin is going to run, and it's going to determine what operating system you're running Maven in. And then it's going to save that value into a variable called the, let me go back here, called the OS detected classifier. And this is important because the proto-C, the compiler itself, is native code. So depending on whether you're running on OS X or Linux or Windows, it's going to use this variable to find the real binary, the actual binary to use to compile your proto definition file. Okay. And the other thing that's really good about this is that you can tie this plugin into your Maven phases, of course. So whenever you're compiling something, it's going to generate the classes for you as well. So that should be it for me to generate the stubs now. So I'm going to give it a try, if this works. I'm shaking right now. I don't know if I got everything right. So I'm going to do Maven install. Oh my God, it works. Amazing. And then if I see what actually got generated, well, first of all, if you see what's in target, it actually downloaded the right binary for me. That's the proto-C compilers and generators. And if I'm really lucky, can I see? No, it's a little bit too. Yeah, there we go. There we go. So I'm not sure if you can see it, but here are the files that's been generated. Okay. So based on that IDL, based on that proto file, I just generated the interfaces for my service. I generated the request payload, also the response payload. Now what I have to do is to implement the server so that I can start the server and also start the service. First, let me implement the service. Okay. So I'm going to go ahead and create a new class. I'm going to say hello service impl. Yes, maybe. And then I'm going to implement hello service. Oh, it didn't find it. But I think I know why. Oh, implement. Yes, of course. I missed the S. Thank you. There we go. And then I can find that. And then I can go ahead and implement the method. Yeah, pretty easy so far. Now, the first thing that you're going to see here, if I can zoom in a little bit, there we go. The first thing you're going to notice is that, hold on a second. You know, in my definition, it's a request and a response, right? In Java, you might be thinking, wait a second, maybe the signature should look like response, right? Greet, and the request. Like, that would be a synchronous way to implement this service. But as you can see, the actual stuff that's being generated that you have to implement looks a little bit different. It actually takes the request in, but for you to respond to or return the return value to the client, you have to do it through the response observer instead. Okay, so it is actually not a synchronous implementation on the server side. It's actually asynchronous by default. Why? Because it is up to the client to determine whether the client wants to block or not. So the client will have the choice to use a blocking stop or an asynchronous stop. But on the server side, it's always asynchronous. Okay, that's why the generated stop looks like that. And then I can just use the response observer to return the value. And the way you return the value, there are three things you can do here. You can do onNext, which is to send the value back to the client. If you have an exception, you can do onArrow to send the exception back to the client. When you're done with this call, you call onCompleted. Okay? And you have to call it regardless of how many message responses you send. Okay? So I'm going to say response onNext, and I'm going to return a response here. So I'm going to say hello response. And the thing that you're going to notice about gRPC is that all of the objects you're going to create, you're going to be using builders. Now, some people like it, some people don't. But in gRPC, by default, like this is the way to do it. You use builders. So you say hello response.new builder. You get a new builder, and then you can set the greeting message, and you can say hello. And you can get the request and get the name. Okay? And then in the end, you say .build, and that's it. I know this is like wrapping a little ugly because the screen size is very small, but let me just show you the whole code again. Yeah, there you go. Okay, so response observer onNext is the actual response you want to send back to the client. You use the builder to build the response object, and you send it back. Now, at this point, just remember, you always have to call onCompleted. If you don't, the string, the client will be held open. It will never return. Okay, even though you're only returning one object, it doesn't matter. You always have to call response observer.onCompleted. That's you really just have to do it. Oh wait, not on arrow. Sorry, onCompleted, just like that. Okay. But the good thing about this generated object is that it actually implements all the two strings. So you can also just print this out very easily. So you can do something like system.out print. And just to make sure this still works. Okay? And that should be it. That's how you can implement the service, just implementing the interface. And finally, I just want to start the server with my interface, with my implementation started as well. And for that, you can use a server builder. And you can say, I want the server to be running on port 8080, and I'm going to build it. And once I build it, I can say server start, starting the server. And then I can say, let's not exit the process until the service has died. And the way I'm going to kill it is by using Ctrl+C for now. Okay. And before I can start this, I have to register my service with this service, right? And to do that, I have to call this method called add service. And with add service, I can do something like this. I can say hello service gRPC. I can bind the service definition directly to the implementation that I just created, which is hello service info. And that is all you need to do to start the server. Okay. Hopefully, this is not very complicated. I mean, this is only a few lines of code. I just took some time to explain what everything does, right? And again, if I'm lucky, I should be able to run this. So I'm going to, oh no, what just happened? Let me see. Reflection, oh, addressing juice. Okay, so this is why I need Spring Boot 1.4, I think. It will actually tell me to with a better error messaging, right? So let me see what is running here. Okay, I found it. Yeah, something else was indeed running. So let me try this again. All right, so this should run. Yeah, it's running. I just didn't print any message. So my server is done. Now I just have to make the call from the client side. Okay, so I have this other project here just to show you that they're actually separate, where I'm going to just make the call from the client. And with gRPC, you don't deal with the bottom, like the TCP connections. You don't even need to deal with the HTTP2 connections. You actually hide all of this complexity by the concept called a channel. Okay, channel is how you actually connect to the server. It hides all of the other complexities behind the scenes and the actual transports behind the scenes. So before you can make the call and generate the stuff for this, you have to create a new channel. And the way you do that is by using what we call the managed channel builder, of course. And for address, I'm going to say localhost, and I'm going to connect to port 8080. And because it's on my development machine, I don't have any TLS, I don't have any certificates or SSL in this case. So I'm just going to say use plaintext is equal to true. And in the end, I'm going to build a server just for development purposes. And that's my channel. And once you have the channel, then you can create a new stub that uses the channel to communicate to the service that you want to communicate with. And the stub is actually very easy to instantiate. Again, there's this helper utility class that usually ends with gRPC. In this case, it's hello service gRPC. And I can say gRPC.newStub. And here you can actually see there are 3 options. There are 3 options you can choose from. Remember I said it's up to the client whether you want to make this call synchronously or asynchronously. So the first stub is blocking, that's a synchronous call. The second one is new stub, it's actually asynchronous call. And the third one is also asynchronous, but you get your response in a future object. Okay? For this demo, I'm just going to do a blocking stub, and you pass the channel in here. And I'm going to assign it to a variable called, not tub. Yeah, definitely not tub. All right, so, and then I can just make the call. I can say greet, hello request, and I can do a new builder. .set name is Ray. And all of those other attributes I created before, you can also set those as well. So I can say set, let me see here, sentiment. Oh, sentiment right here, how happy I am. And this is just a regular enum, and you can just pick and choose which enum you want to use. So I'm still happy right now, so that's fine. And I'm going to build this, and that's it. And I can assign this response to another variable, and then I can just finally print this out. Okay? And that's really it. That's all you need to do to implement your client. But does this work? Does this work? I don't know. I hope so. So I'm going to go ahead and try to run this, being a live demo. You never know. So let me try this. I'm going to use another Maven install and exec. Oh, there we go. It actually worked. So I pass in Ray. Can you see it? Here. Sorry. There you go. So you can see the response message back, right? It's actually making this RPC call. And it's not too hard to write, just a few lines of code. If I see the server, I can see my request object here as well. Now, for some reason, the enum doesn't really show up. I don't know if they just missed it or something. But you can change, you can say set age. I don't know, I'm 10. And I can send that through as well. Okay? It's very easy to do. Let me see how much time I have. 6:05. When did I start, by the way? 5:30? Is that right? Yeah, I started at 5:30. So I have just about 15 more minutes, right? I have until 6:20. Yeah. Okay. Very cool. Any questions so far? Yes, question. Error handling, yes. So let me do that. So let me see here. Give me 1 second. Let me go back to the actual implementation here. So as you can see, the error handling here, you don't really want to throw any unchecked exceptions here. Now what you want to do is by calling what do you call it? The on arrow, right? And what is your name, by the way? Alexi. Okay. So I'm going to say, and by the way, this is just for fun. I'm going to say if request.getName I don't know. I'm just gonna call Alex for now. Okay, I'm going to throw a exception, and sorry, else. I'm gonna do that. Okay. So what I can do here is I can do response observer dot on arrow, and for this one, you can throw anything you want, but I wouldn't really recommend it because on the other side, it would just show up as unknown exception. What you want to do is there's this thing called status, and there's an internal exception you can just use, and you can say with. So here you can actually say what actually failed. Okay, so you can with the description, hello, Alex, or something like that, right? And that's how you can. In the end you say, what is that? As exception. Yeah, there we go. And that's how you can just send the exception back to the client. Okay. Now again, on the client side, if it's blocking, you see that exception. If it's non-blocking, you actually get a callback with the on arrow on the client side as well. Okay. In fact, let me show you how that works. Since we have some time here, I'm gonna try to do two things. First, I'm going to just do a bidirectional streaming by implementing a chat server. Okay. Now think about how you actually do that with like the existing technology with say WebSocket or something else, and just compare that to gRPC and just make up your mind to see which ones you actually prefer. So with the chat server, I'm going to just show you what that profile looks like. 1 second. So here's the profile for the chat. So I have the chat message. I also have a chat message from the server, which actually has the timestamp. I'm getting the timestamp from the server in this case. And I also want to differentiate between the two for now. And then for your service, when you define your service, the only thing that's different here is that whatever you want to stream, you just add a stream keyword in front of it. Okay. So for example, if you just want like server-side streaming, you just do chat message as a request, and then you turn a string to the client. If you want to do client-side streaming, you just add stream to the request parameters here by itself, and then you just return one thing in this service. So if you have stream on both sides, that means it is a bidirectional stream service. Because it's chatting, so when I'm sending something, I'm streaming my chat messages over. I also want to receive the messages back as well. Okay, now how do you actually implement it? This may be a little complex, but let me see if I can blow this up. Okay, so the first thing, I added a few other subcode here, but the one thing that you're going to notice here is that to implement this bidirectional streaming, it's a little counterintuitive. just take a look at this method signature a little bit and tell me what you think. I'll tell you what I think. You are trying to get a stream of messages as the request input, right? And as Java developers, you will be thinking that the signature should look like chat message or something like that, right? And you get a stream of that. And you want to return something to the client, and naturally you will be thinking, okay, I need to return chat message from server stream somehow, right, as a return value, right? That's how you would think the signature should be. But in gRPC, because all of these things has to deal with a lot with the concurrency and also asynchronous server implementation, this implementation that you have to really watch out for, right? If you look at this carefully, what you take in as the argument, as the parameter, is actually the response observer, which is what you want to return to the client. What you actually return as an object is actually a stream observer. It's actually processing the data that's being streamed to you from the client to the server. Okay, this does take a little time to think through because your return value is really what you want to receive, and what you're receiving is what you really want to use to respond. Okay, yeah. Somebody's like, oh my God, no, yeah, I know. So I'm gonna do this very quickly because I only have about 10 minutes left. I think I can finish this. But so this is what I'm going to do. Okay, so what you do is you return a new stream observer of chat messages, and once you implement it, you'll be like, yeah, this actually makes a lot of sense. It actually makes sense. When people are streaming something to you, it's going to trigger any of these callbacks. if there's error that came from the client, it's going to trigger this, and then you can propagate it back to the client and say on error is T. When the stream is completed from the client, you can also close your client's connection. For example, you can do this both ways. You can say that's uncompleted as well. Oh, not that one. Oh, no. OK. Now, what will be interesting is what happens when you receive the message from the client. In this case, I want to propagate it to all of the clients that's already connected to this server. Now, remember, the way you connect, you send messages back to the clients is by using the response observer. And so what I've done here is I'm just adding all of the possible responsive observers instances that's connected right now into a list. Okay, and that list is called observers. So once I receive the message from the client, is what I want to do. I want to just first of all craft the message. So message from the server message is equal to. Oh, sorry. Did I miss something? No. Okay, it's equal to chat message from server new builder. And I can use timestamp, whatever. I'm just going to use a message here. So I'm going to send the same message back. OK, I'm going to do a build. And then what I want to do is to just iterate through the observers. So, oh, sorry, not like that. Iterate through the observers. And for every observer that I already know is connected, right, you probably do a very similar thing with WebSocket as well. For every observer that's being connected, I'm going to say observer.onNext. And the message I want to pass back. Okay, and that's really it. That's really it. But what that also means is that when I ever receive an error, I'm going to also remove my observer from this list. So I'm going to do that. And vice versa, when the observer disconnects, I'm also going to remove that as well. Sorry, this is called the response observer. Okay. And that's all it takes to take care of like this bidirectional streaming. In this particular case, I'm receiving a message. Once I received it, I'm going to propagate it to all of the other clients that's currently connected to me via the service. I think it works. It looks a little bit different from what I saw before. I think I am. And where did that go? Uncompleted? Oh, yeah, there we go. Thank you. Awesome. I'm still missing something here. Oh, yeah, return null, the last one. OK? Yeah, that's basically how you implement it. And then on the client side, here I'm actually using JavaFX. Anybody use JavaFX so far? Have anyone tried it? Yeah? This is my very first time using JavaFX, and I kind of like it. Yeah. And I set up all the look and feel about it already. So all I need to do is to just implement this. I'm going to implement a very short version of this as well. So now I can actually get my chat service stop, and this time it's an asynchronous stop. It's not synchronous anymore. And I can say chat service dot chat, and then new stream observer. And that's the, remember, now in here, you have to wrap your around on this, right? This is what the server is sending you, OK? And because this is what the server is sending you, what you want to do is to basically, whenever you receive a message, you wanna send it to the UI. Okay. So in JavaFX, I need to do run later because I need to run this back in a different thread. Okay. And then what I'm going to do is to basically propagate the message to add it to value.get from. I'm just gonna do message for now because I'm almost out of time. Get message.get message. Okay, that's it. And then when I'm calling the send on action, send. Oh yeah. So send is the button I'm going to click on. That's going to actually send the message, right? And for this one, you're going to get an event. And in this thing, you need to send the actual message as a payload to your chat service. Now, you might be thinking, well, hold on a second. The chat is I already code chat service. How do I actually send another entry, another item into this string? Well, the trick here is that even you code the chat service, it's going to give you back, guess what? Another stream observer, Right? Yeah. And this is like the outgoing messages you want to send through, okay? And now you have this handle on how to actually connect to the stream by sending more of these chat messages to the server via this handle outgoing. And now you can actually do outgoing.onNext, right? And I can say chat message. Now remember, this is all builders. I can set the message to something, and I think it's message.getText, which is another thing that I have already created. Okay, and I think that should be it. I don't know if it works. Yeah, how many people think it will work? Yeah, thank you. Yeah, I know. It's like nobody raised their hand. If you're watching this video, just so you know, nobody raised their hand. So let me make sure the server works first. The server works. That's great. Oh my God, why am I doing this? I don't know. Okay, so here's the chat client. Did it compile? Oh my God, it actually works. Okay, now here I'm going to say hello. Oh my God, it works. It's just one client, right? But that's cheating. That's just one client. I'm going to do another client. Why am I doing this? I don't know. I'm going to do 2 clients now. So I got 2 clients here. Oh boy. If I have everything connected up together, this should work just fine. Again, I'm not sending the name through just because I'm out of time. But I'm going to say hello there. Oh, enter doesn't work. Sorry. Yeah, there you go. And I actually have communication bidirectional with gRPC, just like that. Okay, it's pretty easy to do. Now, I only have a couple of minutes left. I just want you to know that in order for you to integrate with, say, Spring Boot applications, it's pretty. Yeah. I want to point this out. Yeah, thank you. Yeah, so you don't have to do some of these things. There's a project out there, GitHub.com. It's under the repository lognet, and this is actually somebody who contributed to it. The story went like this. I started working on some PR for Spring Boot itself to do a gRPC starter, and then after I have all the code done, they told me, wait a second, somebody else already created it. I'm like, oh crap. So, so I found it, and it's right here, and it's Spring lognet gRPC Spring Boot starter, and it's really nice, and we have exactly the same idea. You can just drop in your proto file, and then in your implementation class, you just say gRPC service. You just add that annotation to it, right? And then it's going to provision the server for you, just like the Tomcat starter, right? Tomcat starter includes the gRPC server for you and start the server for you. In this case, this starter will actually start the gRPC server for you and register all of these implementations that has an annotation mark for the implementation. Okay. And I'm planning to do some contribution here, but just to give you a quick taste of what that may look like, I just show you. I have 1 minute left. I just want to show you some of the things I have been working on. So here is the example gRPC starter project I created I was working on myself. Okay, and for the server, it's really just a standard Spring Boot application. Oh, by the way, I'm using Eureka client here, which is something I'm kind of working on. I can show you a demo real quickly. And then in this echo service, all I have to do is annotate it, and that's it. That's how you can actually run a gRPC server. On the client side, this is even cooler. Again, this is just a gRPC client application, Spring application. And again, in this case, I'm actually using Eureka client. What that means is that when I start my gRPC server, I can register myself with Eureka or any kind of registry that you have with the right port and IP addresses. You can start multiple instances of your service. And then what you can do is to use the client with gRPC. You can actually set a name resolver, which can then use the discovery client to figure out which instance is actually running. And then you can use a load balancer to load balance your request. Okay, so this is a very simple, like with a registry, with the client and the server kind of thing. So let me just run it very quickly because I know I'm almost out of time here. And if I can find my thing here. Who wants to see this, by the way? I don't know. If you don't want to see it, I won't show it. Yeah. I'd rather not show it, just so you know. So I'm gonna kill my server here, kill my server there. That's my client. Okay, and do I want this one? No. Oh shit, sorry. Did I just cuss? Yes, I did. Yeah. Okay, so here we go. So here's the Eureka server. I'm going to run this. Okay. Okay, so that's the Eureka server. And then I'm going to run my, my server here. So I have the first server running, gRPC. I'm going to run a second server here on port 9091. Okay, and now if I go to Eureka instance, 8761, do I see it? Yeah. You see those two instances in the using the right ports, 9090 and 9091. Yeah. And now then for the finale, I'm going to make this other call. I'm going to code this. Oh wait, that's not the one I want to run. Where is it? Wait, hold on a second. gRPC client. Ah, there we go. So that's the one I want to run. And I think what this is going to do is, oh, sorry. Sorry. gRPC client. I may not have this queued up. Yeah. Okay. So if I were to be able to run the client, yeah, I'm out of time. And gRPC.Spring Boot, maybe it's that one. If it doesn't work, then forget it. Okay, it actually works. Oh, thank goodness. And now it's actually sending the traffic through. Now, my load balancer right now is only picking the first one, so it's actually using Eureka to look up which services are running. But because it's using the first service only, it's not actually load balancing at this moment. It's only sending it to one server, right? But if I were to kill this server, it will just pick it up from the second one. Yeah. But if you actually had a real load balancer, it would just flip back and forth around. Okay. So that's really it. That's all I really want to present. So thank you very much. Any questions? I don't know. No questions? Test capabilities. Yeah, that's a great question. How do you actually test this? So the channel that I showed you, how do you do that? So there's you can go to the channel that actually goes over the net. There's also a another one's called internal. Is another internal in process. Sorry, it's called in process channel. So that you can actually just connect to your service in process, so you don't have to go through the net, and that's really good for testing. So what you want to do is to, of course, like you do your interface testing, whatever, and then you will instantiate one of these services, right? And then you connect to it from within the process rather than going over the net, and you can just test out just like you do with every other object that you have. Okay? Yeah. Anything else? Yes, question.
You have to change the model of your objects and you want to maintain several versions.
Yeah. So if you need to say update your message payload, protobuf is actually it's constructed so that you can be backwards compatible. So you can continuously to add new attributes, new fields to that message format. Just don't reuse the same tag numbers. Right? If you reuse the same tag, the numbers, then you're kind of like mixing up the different types together. What you want to do is just to add another field rather than deleting fields. Now, if you really have to delete something, you can reserve the number so that nobody ever actually use it. But you don't really want to just do that. So what that means is that the clients who doesn't have the new fields can continue to send and receive messages from you. Right? You just wouldn't parse it. And the newer clients can use the new fields, so you can continuously to upgrade your application that way. Yeah. So it's fully backwards compatible in that case. All right. Cool. Any other questions?
Sorry, no time for more questions.
Yeah. Okay. Well, thank you very much. Yeah.